All right, what we're going to do is we are going to work on how to draw an orbital filling diagram. To do that, we need one of the sub-level terms that we talked about before, and a nice random sub-level to talk about is 5p to the fourth. Oh, doggone it. I have to love technology. I'm still mastering this pen now. All right, so 5p to the fourth is what we're going to talk about. So what we discovered, right, is there's this word orbital in here, okay? And it's used a lot by chemists, and it's used a lot interchangeably. But what I want you to do in your brain when you start thinking about orbital filling, I want you to think about orientation. Ooh, man. You're getting the full experience here of how it looks when I draw on a whiteboard in my class. The handwriting there is not much better, let me tell you, folks. So, orientation. Orbital filling here. Orbital means orientation. Chemists like to use the term orbital sort of interchangeably. They'll talk about orbitals as sublevels. They'll talk about orbitals as orientations of the sublevels. Really, the word is somewhere in between. But in our brain, these two should be linked, right? When we talk about orbitals, we're talking about orientations, and so I want you to be able to go back and forth on those, all right? So what I need to know is how many orientations can I expect for the P sublevel? Well, if you look up in your notes the P sublevel, you should remember it's got that weird double drop shape, and its orientations are along each axis, Z, X, and Y axes, and so it has 3 orientations, all right? So in this orbital filling diagram, orientations, there we go, 3 orientations. What we're going to do is we are going to draw 3 orientations, and we're not going to like draw the actual shape of this. That takes way too freaking long. What we're going to do is we're going to draw 3 lines. 1, 2, 3 lines. Those 3 lines are the 3 orientations of this sublevel. So we have 5p here, 5p here, and 5p here. Some folks you'll see, if you look this up and you see folks doing this online, they will only draw it under 1 line, or they'll make like a huge 5p and 3 small lines underneath it. It doesn't really matter which way you draw it. What I'm going to do, though, is I'm going to tell you about 2 rules that govern how we draw these orbital filling diagrams. The first one is called the Pauli. Some people call it the Pauli exclusion principle. Some people call it the Pauli spin principle. Just went ahead and erased all that. There you go. Principle. All right. The Pauli spin principle. Basically, Wolfgang Pauli was his name. He was a very German man. Wolfgang was, and Wolfgang came up with this idea where what he said is each orientation, there we go, can hold 2 electrons of opposite spin. So it's kind of neat. He actually did the math, and he actually figured out that their spins are like 1/2. And if you're really curious about it, you can look up what a lepton is. And electrons are leptons because they have a spin that's not a whole number. But anyways, your brain starts to explode whenever you think of that. We're not going to worry about that. What we're going to worry about the fact is, well, if we've got electrons of opposite spin, we're going to have a little shortcut here on how to draw that spin. We can have one that spins like that, or we can have one that spins like that. So you can put an electron in each orientation, right? You can put 2 electrons in each orientation, as long as you put 1 up and 1 down. Simple enough. That's the Pauli spin principle, or some people call it the Pauli exclusion principle. I'm going to add exclusion up here just in case, because you never know which term you're going to. One of the things you're going to see about chemistry a lot is we often disagree about simple words. Yeah, why fight about math when you can argue about Simple words. That's kind of the chemist motto. But anyways, the Pauli exclusion principle, Pauli spin principle, each orientation holds 2 electrons of opposite spin. And then we have another one called Hoons Rule, which states that an electron will inhabit, and I'm going to put inhabit in quotation marks here, an empty orientation before it will inhabit a half full. And luckily enough, both of these are going to come up in this drawing right here. So Hoons rule, an electron will inhabit an empty orientation before it will inhabit a half full orientation. So what that means is, as I come up here and I start drawing the electrons in here, so we're going to come back up here, we're going to draw these electrons. Ooh, I could change the color, but I'm not going to do that. All right, so what we're going to do is we are going to put electrons in here. How many electrons am I going to put in there? Well, I've got 4 that I need to add to this drawing, right? So the 4 that I'm going to add, I have to follow Hoons rule. We have to put an electron in an empty orientation before it will inhabit a full one. So I've got 3 empty ones here. I can pick any one that I want to start with. Doesn't matter which one you start with. But what I'm going to do is I'm going to start with the left one. I'm going to put an up arrow in that left one. All right. When I put the next electron in, right, that's 1 electron down, 3 more to go. When I put the next electron in, it can't go right here, right? It cannot go because according to Hoons rule, we have to put an electron in an empty one before it will inhabit a half full one. So because there's already an electron in this orientation, we have to go to the next orientation. And we have to put 1 there. And I'm going to put another up arrow in that one. And then the third electron, well, here's another empty one. We have to go to an empty one before we can put 1 in one of these other ones. Now I have 1 more electron left. I have to draw 4. I have to put 1 in one of these. It doesn't matter which one I put it in at all. I'm going to put it in the first one because it makes most sense to me. I cannot draw an up arrow. If I draw an up arrow, I'm not following the Pauli spin principle, which states that I've got to put 1. If I've got an up one, I have to put a down one. And that's how you draw. That right there. It's a jumbled up mess here. But that right there is how you draw the orbital filling diagram for this. You're going to practice this a couple of dozen times on the worksheet.